Good morning, guys. Welcome to school. This is going to be a video about the laws of logarithms. This is actually, or they are actually, a very useful tool whenever you want to change from an exponential model into a more linear plot. So what the laws of logarithms allows us to do is to turn basically exponential expressions into some linear form. Okay. So with that said, let's go ahead and jump right in. So we have essentially four laws. The first one deals with the product of two things. If we take the log of the product, then we can express that as a sum. And a sum looks a lot more like a linear term. Okay. Now also, if you're modifying the term inside the log by putting an exponent in front of it, then you can also put the exponent at the front, just like so. So you would multiply the exponent times the logarithm of your initial term inside the log. Third law is going to deal with the quotient, the log of the quotient, and you can express that as a difference or a subtraction. Okay. Last thing is you have this very tricky thing, the log of a of any base, right? A is any base, and the log of any base of 1 equals 0. So now what that essentially says is that, for instance, you have the log of 10. Okay, so my base is 10, and you have 1 and equals 0. So that just means that my base 10 to the exponent 0 equals 1. Is that true? That is true. So now let's, for example, let's look at the log of 10 to the 10 equals what exponent? Well, we don't know, so let's put an x. All right. Now this is saying that the base to the exponent x equals 10. Well, what could x be? The only choice you have is x equals 1, because x to the first power is 10. Okay? Now let's go and do another one, another example. For example, let's say that the log of 10 of 100 equals some exponent. Okay? So that just means that 10 to the exponent x equals 100. Now the only way you can, well, I mean, there's several things, right? You can say that your only choice is 2, because 10 squared equals 100. Okay? So that is essentially the idea of logs, right? We're turning something that looks of an exponential behavior, that has an exponential behavior, and we're turning that into a linear form. Let's go ahead and do some examples of what I just described, and hopefully we can gain a little bit more insight into how to express non-exponential or non-linear terms into linear terms using the law of logs. Okay, so now we have the expression of the log of 4 times m squared. So what I like to do is obviously write log and write my parentheses, but inside the parentheses there's definitely two terms, so I want to make sure that I differentiate between those two terms. By differentiate I mean just separate them. Okay, so since I have two terms, I can write this product as a sum. So I have the log of 4 plus the log of m squared. But now I can further simplify this by saying that, well, I have an exponent right here. So that exponent I can actually express more linearly as this. The log of 4 plus 2 times the log of m. Okay, and now let's look at our choices. So the only one that makes the most sense would have to be answer choice number 3. Okay, so that is one example. Let's go ahead and do another one. Okay, now this one deals with a quotient, and it's saying we're taking the log of L, and L equals x squared over k. So now let's write the log of L equals the log of x squared over k. There's definitely two things. Since this is a quotient, we can definitely express this as a difference. So let us say that the log of x squared minus the log of k. Okay, simple enough. We have one of these logs that has an exponent. So if we have an exponent, we can put it at the front. 2 times the log of x minus the log of k. Okay, and that would be answer choice number 3 again. So, wow, okay. Be cool if this one was 3 again. Alright, so let's see. This is a very similar problem, but this time our term that has the exponent is at the bottom. So now let's say that the log of u equals the log of x over y squared. Again, this is the log of a quotient, so we can express this quotient as a difference in order to make it more linear. So we're going to say that the log of x minus the log of y squared, okay, and we can express this term into this times the log of y. Alright, okay, so let's see which one gives us the answer. So this time we have answer choice number 1. Forgive me if I'm going a little fast. This is a topic that should have been covered in Algebra 2, but I am actually reviewing it because this is going to appear again in calculus. So let's move on to the next one. Okay, so we have something tricky here. We have some product, right? But it's inside square root. Now, a lot of us are not used to this, but essentially we're saying that the square root, right? If we say, for example, we take the square root of x, we can also express this as x to the 1/2, okay? And similarly, if we take the cube root, we can express this as the cube of 1/3, and so on and so on, okay? This is sort of a rule of exponents, but let's take this into account, okay? Now, we can write this log of the square root of xy as the log of xy to the 1/2, okay? And we can put both to the 1/2 because they're being multiplied and they're inside the square root. Now we can also write this as 1/2, right? The log of xy. Okay, and what do we have now inside this parentheses? We have the product of two things. So we can write it as 1/2, and we say the log of x plus the log of y. Alright, and they're both being multiplied by 1/2 because their exponent is 1/2. So let's see, we have answer choice number 4 as being the most appropriate choice. I think I have one last one. Alright, this is actually kind of a culmination of everything we've done in this video. So let's see, we have the log of x equals the log of 8 squared times the square root of 5. Okay, so we said that the square root of 5 can be expressed as 5 to the 1/2. Okay, and of course 8 squared is just 8 squared. So since this is the product of two things, we can express this as a sum. So that is going to be the log of 8 squared plus the log of the square root of 5. Okay, and the square root of 5 can be expressed as the log of log of 5 to the 1/2. Okay, since we have two exponents, we can put them at the front. So I have the 2 times the log of 8 plus 1/2 the log of 5. Okay, and that would be answer choice number 3. Okay, so I hope this video helps you, and it's just a review of the laws of logarithms. If you need more support, feel free to email me on Google Classroom, and I'll be able to sort of guide you through this assignment.